Okay, this is a short little lesson on matrix multiplication. Now with matrix multiplication, the order matters, the size matters to be able to multiply them together. So matrix A, this is a 1 by 2 matrix. Matrix B here is a 2 by 1. The number of rows and columns, okay, again, it makes a difference. So the number of columns in the first matrix must match the number of rows in the second matrix. Okay? If those two numbers are the same, you can multiply the matrices together. The outside two numbers, the 1 and the 1 in this case, dictate the size of the new matrix is going to be. So I'm going to do matrix A times matrix B. Okay? I have a 2, 5, okay, a single row matrix that's going to multiply the column matrix 1, 4. And when I'm multiplying these things, I'm going to follow a little pattern where the first matrix I'm going to go sideways, the second matrix I'm going to go down. And as I'm doing that, I'm multiplying and adding. Okay? So my resultant matrix, I said, is going to be a 1 by 1 matrix. Just one single term. So I'm going to go across, I'm going to go multiplying and adding as I go. So the first matrix I'm going to go sideways, second matrix I'm going to go down. Multiplying, 2 times 1, and 5 times 4, so 2 and 20, and multiplying and add. So 2 and 20 add to 22. I multiplied those two together. I had a 1 by 2 matrix that was multiplying by a 2 by 1 matrix, and that gave me a resultant 1 by 1 matrix. Okay? Again, the middle two numbers dictated that yes, I can multiply the two together if they're the same. So looking at another example, here I have a 2 by 3 matrix. This is a 3 by 1 matrix. I can multiply them together because the number of columns equals the number of rows. My resultant matrix is going to be the outside two numbers, which is, it's going to get me a 2 by 1 matrix. So if I'm going to write them out, I'll write them out side by side. 3, 5, 1, 2, 8, 6 is going to be multiplied by 3, 4, 5. So again, with the first matrix, I am going to go sideways, and then the second matrix, I'm going to go down, and I'm going to do multiplying and adding as I go. It's going to give me a 2 by 1 matrix. So let's start. Start with the first row going across, and then my column going down, multiplying and adding. So 9, 12, 5. 9, 20, 5. So 29 and 5, okay, that is 34. Now I've done that, so now I'm going to go down to the second row and do the same thing, multiplying. 6, 32, and 30. So 6, 32, and 30. Okay, so 6 and 32 is 38, plus another 30 is going to give me 68. And there's my answer. I'm multiplying and adding, going across with the first one and going down with the second one. Again, let's get to some other examples. So I'm going to multiply these ones together. This is a 2 by 2 matrix, okay? And this is a 2 by 3 matrix. The middle two numbers are the same, means I can multiply. The outside two numbers is going to give me what the resulting matrix is going to be. It is going to be, my answer is going to be another 2 by 3 matrix. So going across and going down. So let's do the first one. Okay, so I have multiplying and adding. 4 and 32. 4 and 32 gives me 36. Move on now to the second. So I'm still going across in the first row, but now I'm moving over to the second column. So it'll be 12 and 40 is 52. Now go across to the third column. First row still, third column. 16 and 8, 24. Now I've done all the first row. I've got the full first row. So let's move down to the second row. Second row, first column. Going across and going down. So I have 8 and 4. which is 12. Go to the second column. 24 and 5, 29. Go across again. 32 and 1 is 33. So you work your way across. Start with the first row, go column 1, then go column 2, then go column 3. Then move down to the second row and repeat. Column 1, column 2, column 3. And that will give you your answer. Last example, we're going to multiply this 2 by 2 matrix by an identity matrix that is also 2 by 2. Inside numbers are the same, means I can multiply. Outside numbers gives me my resultant matrix, which is going to be, again, another 2 by 2. So when you multiply something, so if I go matrix G, and I'm going to multiply it by matrix I, when I'm multiplying it by an identity matrix, 1, 2, 4, 5, which is a square matrix with 1s on the diagonal and 0s everywhere else, 1, 0, 0, 1, my answer, if I was to go multiplying across and going down, it would actually give me the same original matrix, my matrix G. It's going to end up being the exact same thing. Multiplying by an identity matrix actually does not change your answer. Okay, if you're going to multiply and add, so 1 and times 1 is 1, and 0 will give me that 1. Go across, 0 and 2 gives me the next one. Multiply 4 and 0 gives me an answer of 4. And then I'm going to have 0 and 5 gives me an answer of 5. It ends up being the same thing. Multiplying by an identity matrix actually does not change your answer. So this is a short little lesson on matrix multiplication. Again, the number of columns of the first matrix must equal the number of rows in the second matrix in order for you to be able to multiply. Thank you very much.